Okay. Okay, problem number 13. It says two parametric equations are given here. Which non-parametric equation can be used to graph the curve? Basically, what they want you to do is to combine those parametric equations to get rid of that part. Hey, Bales, you can't have my hot chocolate. Sorry, baby. All right. So I have x is equal to 1/3 the square root of x plus 3. Y is equal to 4t squared minus 7. And if you glance at your answer choices, you can see all of them are in y equals. So I'm going to go ahead and bite the bullet. Oh, I put an x right there, just as big as a day. That's a t. I'm going to go ahead and solve for t in the first one and substitute that in so that way I don't have to worry about solving for y. If you did it the reverse, in other words, if you solve this one for t and put it back in here, you just have to solve for y afterwards. So that's kind of however you want to do your jam. So I'm going to subtract 3. I'm going to multiply by 3, and then I'm going to square both sides. So that's what I'm going to do right now. Hopefully you can see it while I'm doing it. So I just move those things away from the x, away from the t. So I'm going to square the whole thing. And when I square the whole thing, of course, on this side I get t. On this side, I'm going to, you could multiply it out. I'm not going to. I'm going to be lazy. 3 squared is 9. X minus 3 squared. And again, kind of looking at my answer choices, none of those have that parentheses thing multiplied out. So it's hard to get that. If you had gone all the way through and multiplied it out, hey, Bales, you can't have my hot chocolate. Multiplied it out, then you would have had to do something like completing the square to get the right answer, or you would have had to multiply out the answers. So watch as you're going. There's my test taking on this problem. Is to watch as you're going as to what your answer choices look like. Okay, back to the problem at hand. So I'm going to take this and I'm going to substitute it in up here. So I get y, whoa, is equal to 4 times substituting this in for t. Don't forget that t is squared as well. All right, so I have minus 7 on the end. Unfortunately, all the answer choices have minus 7 on the end. It does not look like there's any way I can get a fraction, so I can pretty much rule out A and B. So I'm down to C and D. This square by the power rule has to be given to the 9 and to this. So 4 times 9 squared is 81. X minus 3 to the 4th minus 7. 4 times 81 indeed is 324. So they wanted to save you the trouble of multiplying that out. So they chose to let you leave it like this, but sometimes I think that's more confusing. So that is answer choice D. All right, moving on to problem number 14. I have dinner waiting on me and I'm ready to go have dinner, but I want to get this done first. Formula for the sequence is shown. Let me get my cheat sheet out. 12. I already did 13, 14. All right. So I tried when I started doing this problem. I was like, okay, what's the formula for arithmetic and geometric and all that good garbage? And it turns out it's neither one. So that's not really helpful. But what I can look at is I can look at the terms. I can figure out what the next few terms of this are going to be and then compare them to the ones down here. So that's basically what I did is I used this, found the first few terms, and see which one of these formulas worked out as well. So just so that I can prove it to you, to find a sub 2, I'm going to put I'm going to say 2 times a sub 2 minus 1, which is a sub 1, which was 3, and then plus 3. So 2 times 3 is 6, 6 plus 3 is 9. And this is, I'm using the formula that they gave me in the problem, the original one. So a sub 3 is 2 times a sub 2 plus 3. 2 times 9 is 18, 19, 20, 21. And if you want to be really efficient, you can keep going on and on. So then I'm going to try answer choice A. And I'm going to put, so if I want a sub 1, I'm going to say 3 times 2 to the first power minus 1. And let's see if I should get 3 because that's my a sub 1. There's my a sub 1. at the top. So I should get 3 if it's the right one, and if not, then I can quickly move on. 2 minus 1 is 1. 3 times 1 is indeed equal to 3. So you should be thorough and check a couple of other answers. 2 to the second power minus 1. So 2 squared is 4. 4 minus 1 is 3. 3 times 3 is 9. Oh, let's try one more since that's how far I went up there. 3 times 2 to the third minus 1. 2 times 2 is 4. 4 times 3 is 8. 8 minus 1 is 7. 7 times 3 is 21. So indeed, it does all work out. So our answer choice is A. I did check a couple of the other ones. You didn't need to go much past the first term just to make sure that the answer choice A was correct. All right. Moving on to problem number 15. It is a geometric series problem. Remembering that series and sequence, the difference is that in a series you add all of the terms. So for what it's asking us, 15, it is asking us to find the sum a to 1 to infinity, right? It tells me that my A1 term is 25,000, and it tells me that 0.8 is going to be my R. And remember, that's to the nth power. Now, having said all that, did you really have to write that? Nah. You just have to remember this problem. So for an infinite series, the sums is A1 to 1 minus R. And actually, you don't even have to remember. You just have to remember how to use it, because this formula is listed on your formula card for pre-calc. Aren't you lucky people? All right, so the sum of this, this only works as you are going to infinity. So, and it only works if R is less, if the absolute value of R is less than 1. Okay, very important. If it's a number bigger than 1, it does not have a sum. It diverges. Dun, dun, dun. All right, so the sum of this, A1 is 25,000 divided by 1 minus 0.8, which we all know is 0.2. And when you put it in your calculator, you get A. You get A as your answer, which is exactly what I did. Let me double check to make sure my answer is right. 15 is indeed A. Cool. 61 of the students testing in pre-calc got that one correct. Aren't you glad to have known that? All right, 16 is a problem that you will graph. I do not have a grapher that I can put on my phone at the same time, but I just encourage you to put it into Desmos and to look what's happening as you're coming from negative infinity, and look what happens as you're going to positive infinity. The answer choice for this one, which we would have graphed to get the answer, is indeed B. Is B. If you wanted to look at it and try to figure it out, which there's nothing wrong with that. Sometimes it just is easier just to graph it. So the smaller the number we put in there, it's actually going to the larger the number we're going in there to put in there, this is actually going to get smaller, and so we're going to end up having 1 plus 0, which is 100. So that's the reason that one is and this is 16, and the reason it goes to 0 is for a similar reason. Because your answer at the bottom is going to end up helping that go to 0. But like I said, my suggestion would be to graph. I was talking to my Sydney about this because I said, hey, do you remember doing limits? You want to help me out so I can maybe give my kids a different perspective? And she said, to be honest, once she gets into calculus, you don't use the primitive methods anymore. You actually use derivatives, which we were not expected to talk about. So our rules say that we should find them graphically, algebraically, and numerically. And speaking of numerically, in number 18, in number 18, which is the one we had to do, if you put that number in for number 18, it says the value of as x approaches 3. If you put it in, you will get answer choice B. You just literally put it in and you get answer choice B. But one thing that you should be cautioned of, and we talked about this like in our very first chapter or second unit, where if it were being divided by something and there would have been a whole, meaning a whole that you have to be careful that there is not discontinuity in that case. Okay? All right. Moving on. My last problem I think that I'm supposed to do. Oh, nope. I got 2 more. Oh, 3 more. 21. Here is this graph. So it wants to know the sum of its series. If you do a little investigating on the terms, you will see. Actually, I'm going to pause this. I'll pick it back up because I'm trying to not make the videos too long.